Earth Science. This is Miss Satterley, so I'm going to talk about volcanoes today. I want you guys to watch this in class. Volcanoes are mountains that form when magma reaches the surface. So magma is actually molten rock that is underneath the Earth's crust. Formation of a volcano. Volcanoes can form different ways, and we'll talk about that later. Some form at hot spots and other structures. A picture of the difference between volcanoes on Earth and Mars. So Earth has plate motion, so the plates are constantly moving. So a lot of the times volcanoes are going to form chains or volcanic mountains. Hawaii is an example of this. On Mars, though, when at one point it did have volcanic activity, there's actually the largest volcano in the solar system on Mars called Olympus Mons. But it was just one volcano in one spot, and that's because Mars does not have plate motion like Earth does. So when magma rises, it's less dense than solid rock, so it's able to erupt from the surface, and it cools and forms volcanoes. So how a volcano erupts, it's similar to when you shake a bottle of soda. Magma has a lot of dissolved gases in it, such as carbon dioxide and water vapor. Those gases, when they approach the surface, they're going to have a lower pressure, which causes a rapid expansion, and we get an eruption. An eruption is when gases escape, propelling magma upward. There's two types of eruptions we'll talk about. Molten material is the next thing I want to talk about. We use two different terms, magma and lava, and they have a difference. Magma is the molten material that forms underground. It's a mixture of molten rock and gases. And then lava is going to be the magma that flows onto the surface, and we use a different term when it reaches the surface. And this is because those gases that were once inside of it are no longer there. So the magma chamber is the first thing I want to talk about. This is a pocket underground where magma collects. Magma accumulates and pressure accumulates, causing eruptions. There's large magma chambers underneath all volcanoes, and eventually the pressure is too great, and that's how we have an eruption that forms. Volcanic pipe is the next structure. This is the channel that connects the magma chamber to the vent, and this is where magma rises. Vent is the opening in the ground where magma escapes. Most of the time, volcanoes are going to have one central vent. Sometimes they'll have side vents where magma releases as well, and those can be more than one. But traditionally, volcanoes are going to have one central vent on the top. Craters can form. This is a bowl-shaped pit on the top of a vent. Sometimes when you have a dormant volcano, craters can actually fill up with water, and we get a crater lake, and that's what is pictured here. Caldera is another term I want to talk about. This is a huge depression at the top of the volcano that's caused by a collapsed hollow shell, and that's when the vent itself will actually collapse back on itself, and calderas can be at the top of volcanoes as well. So now I want to talk about eruptions. Eruptions can be explosive or quiet, and this is going to depend on the magma characteristics that we have in that particular volcano. So magma varies in viscosity. It can be either high viscosity or low viscosity. High viscosity is going to be thick and resist flowing. It can get clogged, and that's actually can cause explosive eruptions. Low viscosity is thin and flows easily, so those will be more quiet eruptions, and they're not going to have as much damage to them. Three main factors are involved when we have determined the viscosity of magma. That's temperature, water content, and silica content. The higher the temperature, the lower the viscosity. So this is the same concept. If you heat corn syrup, the viscosity is going to lower and it's going to flow more easily. Water content, if you have more water, it's going to flow easier. If you water down any substance, it's going to flow more easily. So that's another common concept. Last one is silica content. Silica is a type of rock or sediment that can be found in magma. If you have a high amount, you're actually going to have a higher viscosity. So the more silica you have, the more resistance to flow. And silica is going to act like a glue, and it's going to have strong bonds. So let's talk about the two types of eruptions. First, we have quiet eruptions. Quiet eruptions are the result of very hot, low silica magma, and this means that their viscosity is going to be lower. It's a stream of lava, and the lava that flows from quiet eruptions can actually travel great distances. There's two types of lava that you can get from quiet eruptions, Bahoe and Aa. Bahoe is hot, fast-moving, and it actually forms a rope-like surface, and that's what this picture is. Aa is a cooler, slower-moving lava, and it has more of a chunky, crumbly appearance, and that's what the bottom picture is showing. Now, explosive eruptions are the result of high silica magma that have low water content and lower temperature. It's a very thick magma, and it can actually cause the volcanic pipe to clog and the pressure builds up, resulting in those kind of classic volcanic eruptions that have a lot of ash and dust involved in them. They go really high. The different types of lava that can be the result of explosive eruptions include cinders, lava bombs, and ash and dust. And this is because the lava is going to solidify quickly. So cinders are pebble size, and lava bombs are large chunks of lava. They actually can be the size of a car, and they're blown up into the air. Volcanic locations. Volcanoes can stay at plate boundaries. Converging and diverging are going to have different ways that volcanics form. At converging boundaries, the oceanic plate is subducted into the mantle, and this is actually going to cause it to melt, and then the magma is going to shoot up from the magma chamber. So that's one place that volcanoes can form. The next one is diverging plates. This is where magma rises, filling the gaps between the plates. That's another way we have volcano locations. And the Ring of Fire is an example of converging boundaries. Now, hotspots volcanoes are the next one. This is when it doesn't happen at plate boundaries, but there's a region where the magma actually just breaks through in the middle of the plate, and it's where hot rock extends deep within the mantle to the surface, and this is going to form shield volcanoes. The next location that we can have are mid-ocean ridges and then subduction zones, which form composite volcanoes. There are three types of volcanoes. They're named for their shape or their interior structure. They include shield, cinder cones, and composite. First one is a shield volcano. Shield volcanoes are broad, gently sloping volcanoes. They're going to result from quiet eruptions of low viscosity lava. And they're going to have hot flowing basaltic lava, which can travel long distances before solidifying. It produces a wide, flat volcano, and that's what the picture is right here. So they don't have a cone at the top. It's more just a broad, low, not very high volcano. Next one is composite volcano. They're tall with steep slides, and this forms from explosive eruptions. And composite volcanoes are actually built up from layers of lava ash and volcanic bombs, and they will often have those secondary vents found on the side of them. Last one is a cinder cone volcano. Cinder cones are small, steep-sided volcanoes. They're eruption of entirely ash and cinders. Most of the time, they only erupt one time, but they form from debris ejected into the air, falling back onto the volcano itself. And that's a picture of a cinder cone. It looks very ashy and very crumbly, and that's because of the ash and cinders that are involved. Now I want to talk about one of the types of rocks. We'll get into rocks. I don't know if we'll have time to do them before second semester, but if not, they'll be the first thing we do. So igneous rock is a rock that forms from magma. There's two types of igneous rock. Extrusive and intrusive. So extrusive, X means exit, so that's the rock that cools on the surface, and then we have intrusive, which is where it cools inside the earth. Intrusive rock I want to talk about first. This is igneous rock that forms underground from hardened magma. It's going to cool slowly underground, so there's going to be crystals that form, and the crystals are going to form from the elements solidifying, and you get more of a coarse grained texture. Now, extrusive rocks are different. This is when igneous rock that forms at the surface. Crystals are not able to form because they cool too quickly, and you have more of a fine grained texture, and that's because it cools very quickly at the surface. The picture here is a picture of obsidian, which is called volcanic glass, and I'm going to talk about that in a few slides. Color of rock. The color of rock is actually going to give you a clue to the composition of it. It's going to depend on the type of magma that we have. Rocks that are rich in iron and magnesium are actually going to be dark and dense. Two examples of that include gabbro and basalt. Gabbro is an intrusive form and basalt is extrusive. The amount of silica content is also going to affect the color, and also if it's less dense is going to be lighter in color. And granite is a coarse-grained intrusive rock that is formed from less dense igneous magma. Two examples include obsidian and pumice. I'm going to talk about obsidian first. This is dense volcanic glass. There's no crystals within this, and that's because the lava cools really, really fast. It's usually black in appearance. Sometimes it can have some brown within, but it has a very glassy appearance. Next one is pumice. Pumice is a light sponge-like rock. It's found at the surface of a lava flow. When we watched the Vesuvius video, we actually saw they talked about pumice. The unique thing about pumice is that it has holes in the rock, which causes it to float in water. And it's the only kind of rock that can actually float. Now I want to talk about hotspot volcanoes. Hotspot volcanoes are going to form shield volcanoes. Hawaii is actually an example of a hotspot volcano, so the Hawaiian Islands. Hotspots, again, are located in the middle of the plate, and that's because the magma breaks through the plate itself, and it can create a chain of volcanoes. Igneous features. This is the last thing we'll talk about. There's 4 types of igneous features I want to discuss. Igneous features are going to be features in the rock that are formed from magma. It includes batholiths, sills, dikes, and volcanic necks. Batholith is the first one. It's the largest type of intrusive igneous rock mass. It can actually form in the core of mountain ranges, and it's going to extend into the Earth's crust. Next one is a sill. Sill and dikes are similar, and the way you have to remember them is the structure that they form. So they're basically the same thing. A dike is going to cut across rock layers, while a sill is going to be parallel to the existing layers. So if you look at the picture here, looks like a band running through the rock. That is the sill, which is a structure formed when magma hardens in a crack parallel to existing rock layers. So it's cutting through those layers. Now, dike is the gray that's forming in kind of the reddish brown, and that is when magma hardens across rock layers and cuts through it. The last one is a volcanic neck. This is a structure that forms when magma hardens in a volcanic pipe, and this is a picture of a volcanic neck that could be quite large. And the last one is lava plateaus. These are features formed from extrusive igneous rock. This is when lava can flow onto a large surface and cover a large area and then solidify. Last one, we have a cross-section of a stratovolcano, which is another name for a composite volcano. This picture will be important for one of the homework assignments that we'll have coming up. So if you have any questions, please let me know. Bye.